Today we are going to explain you the exponential function. I'm not going in much detail, but yes, I'm giving you some introduction about exponential function. That function is f defined from r tends to r positive. So you can see that fx equal to bx. If you can see that b here, I'm taking b greater than 1. In class 12th in NCRT, this b is greater than 1, but in class 11 or in RD Sharma or in some other books, you can see that b can be greater than 0 but less than 1 case also. Here we are casing only this case b greater than 1. So this is my request to those who are preparing for some higher level, they will also consider that case, this b greater than 0 and less than 1. So I'm also going to explain you little about this case when b is greater than 0 and less than 1, but not going to discuss this in much detail. So for further you have to see other sources, RD Sharma of class 11, so that you can get the all details. So here I'm taking this particular case that fx equal to bx. This is called the exponential function. Domain of f is r, you can see there r, and range is 0 to infinity. Means the answer of this cannot be negative if b greater than 1. So in general, you see, you take the example b as suppose b is 2 and x, you take the values of x as you first take x equal to minus 1, you take, then it will be 2 minus 1, and 2 minus 1 is 1 by 2. So y will be 1 by 2, the some point will come x equal to minus 1, 0.1 will come here. Then if you put x equal to 0, then y will be 1. So this is the point 0 comma 1, and if you put x equal to then 3, then this function will go like this. So this is for example, this is taking, this is 2x, and if you take 3x, then it will be going steep this way. It will be going, 3x will be going, and it will be coming more closer to this x-axis. And if you take b equal to 10, and then this will be even go more faster, this upside, and going will be very close to this x-axis. Here some important point is that this graph will never cut this x-axis. You can simply understand this why this will not cut, because it means if this cut x-axis, it means the y has to be 0. Then y cannot be 0 in any of the case, whatever the value you take of b and whatever the value of x you take, but y is not going to be 0. So this graph will never cut this x-axis. Now note number 1 is, like, if I take this base, particular base, if I take as 10, then 10x is called the common exponential function. And note number 2 is that fx equal to ex is called natural exponential function. E is approximate value of e is 2.711282 dead dash. This is a non-terminating, non-recurring number, and you can see this actually this e has this symbol 1 plus 1 upon 1 factorial, 1 upon 2 factorial, and this answer is lying between 2 and 3. So we can say this e is lying between 2 and 3. So but the approximate value that we use for e is 2.7182. Now this is done. Now the differentiation of that exponential function is ex. But you can see, if base is not e, if base is other than e, then it is the normal exponential function, and we take log both side. So this will become log y and log ax. So x will come here and log ea. So these are the properties that I'm using for this function. So this is, you differentiate with respect to x, this 1 upon y dy by dx, this log ax, this is x, and the rest of the thing is constant. Log e a is constant term, so only differentiation will be done for x. So this is 1 dot log ea. So from here dy by dx will be y log ea. So dy by dx is ax, y, you see y is ax, so this is ax log ea. So this is the exponential function in general, and you can take the example, you can take some cases, those who really want to study that at higher level, you take this b 0 to 1. Better you take some example, let's say b equal to 0.5, and then you start putting the values. That b, first you put 1. If you put x equal to 1, then 0.51 means 0.5, the point will be coming here. Then you put x equal to then 2, then 0.5 square will be very short and the value will be coming very close here. So you see that how this graph will be moving. So this is what you have to see that how this graph will be moving. Take 2-3 examples. In particular case, you take b equal to 0.5 and you just see how your graph will be going and what are the differences that you will see in that case. Okay. Now we are going to define this logarithmic function, that function from r positive to r, where f is defined by fx equal to log bx. Here b we are taking greater than 1 as we have taken in case of exponential function. Now domain of f is, you can see that 0 to infinity. That's why I was saying earlier also that log x is defined only for positive values of x. And range of r, you can see this graph is going from this y, this above this point, this y is positive, below this point y is negative. So means y can take all values. So this range is r, not number 1. Now first you can see that how this has come. If you want to draw this, I'm just telling you how to draw this function. That you take y equal to log this, for the time being I'm taking this base as this log bx, and then you can write that x equal to b y. So you put some values and correspondingly you find some values of y. So you will find some interesting pattern, that the graph will be looking like this, and this graph will always be passing through 1, 0. As you put x equal to 1, then y will be equal to 0. So this graph will be going like this. You can take some example, 2-3 values, positive values of x, you take some positive values of y you can take, and just see that how this graph will be looking like. So this graph will be coming like this. It will be going from passing from 1 to 0. This is the point where it will always be on the logarithmic function, and this is going down, but it is not going to touch this y axis. It's just going to be very close to y, but it will never touch to y axis, because you know that if y is touching this y axis, it means the x going to be 0, but x cannot be 0, as the definition of domain is there, that 0 to infinity. So this graph will never meet this y axis. Now in particular, if I take value of b as 10, then this log 10x will be called the common logarithmic function. And if I take that b as e as I already discussed, e is some 2.7 something value, is approximate value is this. So that time this function will be called the natural logarithmic function. Now some observation is there. See, natural logarithmic function is also written as this way, but I request you that you keep in mind this notation, but don't use this notation, because in CBSE hardly we see this notation. We majorly use this notation log ex. So now what is the observation? The observation is that if you take exponential function that base as e, then this graph will be going like this. And if you take log, natural log or log, then the graph will be going like this. So you can see that both ex and log ex, they are the mirror image of each other along this line y equal to x. So this is very important observation. You should always keep in mind that they both are the mirror image of each other. Now come to this d by dx. If this is log with base e x, then the derivative will be 1 by x. But if it is not, base is not e, base is any other number, then d by dx log bx. Now we know that we can change the base of this log by using this property, and I mentioned this property in the previous class. So this is log e x and this is log e b. You can change this base with this property. Now you can see this denominator is constant, because e is constant, b is constant. So you can take this out and you will differentiate only this d by dx log ex. So now this log ex, we know the derivative is 1 upon x. So in case when you get the log bx and you see that your base is other than e, then you will use the differentiation like this. Now we are going to discuss some more questions of exercise 5.5. This is the question y equal to x, exponent is sin x plus x log x. So you can see this, we have to assume u as x sin x, and we have to assume this v as x log x. So it means this y will become u plus v. So if I differentiate this with respect to x, then this will be dy by dx, and it will be du upon dx plus dv upon dx. So to get dy by dx, you have to find du upon dx and dv upon dx, and we have to solve them separately, and we have to differentiate both the functions with respect to x. So now you can see this function, there x is a function and the exponent is again a function. So it means we have to take log both side. Take log both side. When we are saying just log, we are not mentioning what is the base. It simply means that we are talking about the natural log. It means the base is e. So whether you mention here e or you don't mention, it is the same thing. So this will become log u. This will become log x sin x, and when you if you write this using the property of log, then it becomes you can say this is log x, and x is positive here. So now we'll differentiate with respect to u. So I'm writing this differentiate with respect to x. So it will be 1 upon u du upon dx, and this will become this. You can see this is the product of two function. So this is sin x. I'm taking this sin x first function, and then this is 1 upon x, and if I take log x, and it will become then cos x. So now from here du upon dx will be, u will get cross multiplied. So u is your x sin x, and here you are getting sin x upon x plus this is going to be cos x log x. So this is the value of du upon dx. Now we'll find the value of dv upon dx. So again we are taking log both sides, so this will become log v, this will become log x log x. So you can see this further can be written as log x square. So when I differentiate, I have to use the chain rule, and then chain rule, according to chain rule, it will be dv upon dx, and this will be 2 log x, and then this will be x. Here I am assuming that x is positive. So in the beginning of the question, I can mention this, that x is greater than 0. Let x greater than 0. So if you mention this x greater than 0, then you have no need to put this mode. So from here your dv upon dx will be v. You do the cross multiplication, v is your x log x, and this will become 2 log x upon x, you can say. So finally we are going to write dy by dx. So your dy by dx will be du upon dx plus dv upon dx. Now put the value of du upon dx. This is x sin x, and this is sin x upon x plus cos x log x, plus this is the value of dv upon dx, x log x, and this is twice of log x upon x. So this is the answer. Now consider this question number 12. This is x exponent y plus y exponent x, this is equal to 1. So if this question you take log on both sides, that it will not help you. Why? Because log you have two properties, log a b. which is equal to log mod A plus log mod B, and you have second property that log A upon B as log mod A minus log mod B. So here for plus means log A plus B, we don't have any property or the law of log. With the help of that we can expand this, so we cannot use here log both sides, so we have to take this again as u and v. So let u equal to x y and we'll take v as y x. So this means this will become u plus v equal to 1. And now if we differentiate with respect to x, then this will become du upon dx, this will become dv upon dx, and this is equal to 0 because constant differentiation is 0. So we are marking this as 1. So we have to find that du upon dx, dv upon dx, and from there we'll get some value of dy by dx. So start with this now. This is u x y, so you can see that x has some exponent as a function again, so you have to take log both sides. So this is log u, this will become y log x, y is a exponent, so y will come here. Now we'll differentiate with respect to x, so differentiate with respect to x, and again we can mention this that let x greater than 0. We are in the beginning we are writing that x is greater than 0, so this is okay. You can now write the differentiation directly without using mode. So this will become du 1 upon u du upon dx, and this will become y, you take this y, differentiate log x, so this is 1 upon x, then you differentiate this log x, you take and differentiate y with respect to x, so it will become dy by dx. So your du upon dx will be u, which is x to power y, and this is then y upon x plus log x dot dy by dx. Now see from this side v, you take again log both side, log v equal to x log y. So this is just the opposite. Now you can differentiate with respect to x dv, and this is dv upon dx. From here x log y will be then y, and then you have to differentiate y again, so this is dy by dx, and log y and x differentiation will be 1. So from here dv upon dx will be v, you do the cross multiplication, v is your yx, and this will become x upon y dy by dx plus this is log y. So now you can substitute the values of du upon dx and dv upon dx in equation number 1, and you will get the then you'll, if you simplify, and then you'll get the value of dy by dx. You have to separate the value. Now question number 13, question number 14, question number 15, they are of the same type. So you see that cos x, this is exponent is y, cos y exponent is x. This question cannot be solved if you take this as u, this as v, because there is no property then through which you can solve it separately. So here we will be taking log on both sides. So taking log both side, so it will become y will come here, then log cos x, and this will become x log y. And now after getting this statement, we'll differentiate with respect to x. So here you can see this is the product of two functions y in and log cos x. Log cos x is again the composition of function, so we'll differentiate accordingly. So we'll take y first, and then we are differentiating log cos x. So log cos x will be 1 upon cos x. So this time again we have to assume whether now you cannot assume that x greater than 0 or something, so you have to take here mode. This is cos x, and then cos x, this it will be sin x, and this will be minus. So next one, and you can go with this, this is done, and now you can take log cos x and differentiate of y with respect to x, so dy by dx. So see, basically, if in questions it is not mentioned that what cos x is, what sin x is, so you may assume, or you may use this mode, or you can also use it without mode also, because this is nothing given. So examiner will take you like you have understood, but you mention the rule, but and you use without mode, so this is okay. So this is next here, x you take log y is 1 upon y, then dy by dx, and plus log y, and for x it will be 1. So from these from this relation will separate dy by dx. So this is minus y sine x upon, you can write this mod cos x, and this you write this as you bring this side log y, and this will become then x upon y, and dy by dx you take this log, this is cos x, and this is dy by dx. So now finally you can write dy by dx as this, you can take minus y sin x upon cos x mod, and this is minus log y upon, this is x upon y minus log cos x. So this is your final answer, but it might not be matching with the answers given at the back of the NCERT. Reason being, they might have not taken mod x, they have just taken cos x. So in that case, we'll simply write sin x upon cos x as 10x. So that could be one of the answer, but if you leave the answer here, that is okay. This is the value of dy by dx.